So the question we now need to discover is, are these two triangles similar? Is it a dilation? Now, when you dilate a triangle, we're changing the size but not the shape, correct? And in the last section, when we learned about similar figures, we learned that all of the angles stay the same. They match up in congruent pairs. What happens to the sides? They get larger or perhaps smaller, How did we write out that statement? When we had two similar figures, and we did this in the warm-up last time, how did we express the relationship between their side lengths? Ian?
Like AB over.
So something like,
something like that.
so one of these?
Yes.
A statement of similarity where we fill in the side lengths?
Yes.
Does it matter, for example, if I wanted to start with side AB, could I write it up here?
Yes.
Could I write it down there?
Yes.
Could I call it BA?
Yes.
Sure, why not? I'm going to write it up top for no particular reason. What side does AB correspond to? Which is pretty easy to figure out because they've got the same letters in it, which is why we name it that way. We don't just give it a whole new letter because it's a lot easier to identify if you just keep the letter the same and add a little mark after it. A prime, B prime. Okay. What if I wanted to do this side next? What would I call it?
BC.
Could I call it CB?
Yes.
Could I put it down here?
Oh. You already established which is on the top.
Which triangle is on the top?
The smaller one.
The smaller one, triangle ABC, is on the top. So it's got to stay that way. So am I going to put BC here or here? Numerator or denominator?
Denominator. Hey, numerator.
Denominator is downstairs.
Yeah, I think.
Numerator is
I think
upstairs.
it's a prime.
And then what goes downstairs?
BC prime.
B prime, C prime is how we read it. B prime, C prime. What about the last one? What's my last ratio?
CA prime on the bottom and then AC. CA.
AC on the top, Ian?
Yes.
Same page? AC on the top. Can I call it CA?
Yes.
I don't really matter. AC on the top, and then what goes on the bottom?
A prime, C prime.
A prime, C prime. Very nice. Here we have a statement of similarity. We are hoping that this is true. We don't know it's true. We're trying to find out if it's true. So we put some question marks over those equal signs because we're saying we're trying to figure this out. Do we have side lengths for any of the segments mentioned here? Do we have numbers we can work with?
Yes.
What do we know?
AB is 3.
Maybe it's 3, okay.
B.
Okay. Somebody else give me this one. 5?
What?
Give me this ratio.
4, 8.
Or
Oh.
do we know this one?
No,
we don't.
Figure it out.
We don't know that one. We might need to figure it out. Possibly. So, my question is, are these two ratios proportional? How can we answer that? Let's start with this. What technique could you use to answer that that would result in you being banished from this classroom?
Cross multiplication.
Cross multiplication. Don't. Just don't.
Isn't that the only time?
Friends don't let friends cross multiply.
They don't. Bad. Just say no to cross multiplication. How can I simplify these in order to figure out if this is a proportion? You know this one. You didn't know. How can I simplify this left-hand side here?
You divide them both by 3.
Okay, so I divide the top by 3 and the bottom by 3. What does that result in? 1 over 1 over 6 divided by 3 is 2. Not minus, divide. What about this side? Steve, what do I do with this right-hand side here?
So, would that also be 1/2?
I don't know. Tell me how you get there.
Okay, so 3/6
Right hand side.
I'm taking one step back. 3/6 became 1/2. Am I correct?
You're correct.
4/8 is also equal to 1/2.
Why?
4 plus 4 is 8. So
Yeah, but show me. How are you going to show your process? You can't just say it's the same thing as 1/2. Just show me why. Isaac, you want to help us do that?
By 4 on both. I mean, on top and bottom.
Divide top and bottom by 4. And then what do you get? 4 divided by 4 is?
1/2.
4 divided by 4? 4 divided by 4?
Okay. Hate division.
You don't need to think. Any number divided by itself is 1. 4 divided by 4 is?
Yeah. Anything divided
4 divided by 4
by
is?
1.
8 divided by 4?
4.
Not minus. Divide. How many 4s are in 8? Is this a true statement?
Yeah.
So what does that mean, Micaiah? Alright, I got 1/2 equals 1/2. I already knew that. What does that mean? That these are proportional? These are proportional? So what does that mean about these two shapes? Can't hear you. You gotta speak up. If corresponding side lengths are proportional, what does it mean about these two shapes? They're similar. They're similar figures. And one way to create a similar figure is to dilate, like we learned earlier with my mental image of Steve. We shrunk them down, kept the same shape, different size. This is the dilation. Anybody have any questions on how we know that this is a dilation?
That's not.
Good, I think. So let me add something here. If I wanted to find out the length of this, could I?
Yes, if you wanted to.
How would I do it, Paula?
How would you do it? Yes.
You want to tune back into the conversation?
Yes.
How would I find this sideline if I wanted to?
You would take whatever the A and the C is, and you would multiply them.
Nope. I know two sides of a triangle. I want to find the third. Can't hear Tala. No, I can't hear you.
Oh, okay. What if you do like a 3 times 4 maybe?
What theorem is Tala looking for here, friends?
I know the name.
Yeah.
Pythagorean theorem.
The Pythagorean theorem.
Yes.
What is the Pythagorean theorem? What does it say, Ash? So I would take this side length, square it. Take this side length, square it, add them together, and square root the result. And when you do, you get this. All right, friends, question time. Do not shout out the answer. I want you to think, and if you know it, raise your hand. What's the length of A prime C prime? What's the length of A prime C prime? You think you know it? Raise your hand. Give everybody a minute to chew on it. Hunter, you have an idea? Maybe? A thought on where we could begin? What do you think? Go with your gut. What's your gut say?
Or, wait. Oh, okay. I didn't realize that you had gotten.
Yeah,
Okay.
that one's fine.
Um,
I see 4 hands. I got you in my head. You can rest your hand.
10.
No, he doesn't. Kai, how did Hunter do that?
Square both 6 and 8. That's 36 and 64. Add them together. 100. Square root of 100 is 10.
I did it.
This is very true. This is very true, Hunter. Is that how you did it?
Yeah.
You did the Pythagorean theorem in your head? Yeah? Anybody else have a different way? Takes a lot less work. Ashton?
Just multiply 5 times 2.
Why 2?
Because 3 times 2 is 6 and 4 times 2 is 8.
Ah! So what you're saying is to go from here to here times 2. From here to here times 2. So then from here to here must be times 2. 2 is called the scale factor. It is the number you multiply this by to get the image. So you start here, you multiply by 2, gives you this. Does that make some sense?